Welcome back to the 16th video about my dual engine control lever IP68 project. In the previous video we made some very small parts, plungers, some nipples here for the springs and that little plate here for strain relief. Card here, link in the description. Now it's time to aim for bigger things. That includes the use of the round table, and this video will be about making the round table actually usable. Enjoy! The first and only time I featured this round table was in a mailbag video. Card here, link in the description. In the same mailbag video I featured these T-slot nuts that should be used, or I intended to use in conjunction with that round table. However, there's a little problem. They do not fit in here because, Chinese table, the shoulder height here is only 5.4 millimeters, and these T-slot nuts, which are sized according to ISO or DIN, have a shoulder height of 5.8 millimeters. So we will have to mill off 0.4 to 0.5 millimeters here. That's actually the first time I'm milling steel in my little milling machine. And I have here a 5 millimeter diameter end mill in, and of course, because it's steel, we will oil things a little bit up just to make things easier. So I will go down here and then I'll touch off and then I'll advance 0.1 millimeter at a time, I guess. The first 0.1 millimeters were not too bad, but I got some vibration here, mainly in the camera, so I will show you the second 0.1 millimeter. Okay, 0.3 millimeters to go. I come back to you when I'm finished. After cleaning up all the edges with a file and deburring here, the hole doesn't look too bad, and more importantly, the nut is now fitting in here. Okay, 3 more to go. And there you have it, a round table with 1, 2, 3, 4 T-slot nuts. It has been approximately 3 weeks since I took the last take you just saw. That was shortly before Christmas. Now we are 1.5 weeks into the new year, and I'm about 1.5 weeks into a flu. So there's that. Anyway, the question arises now, how can we center up our workpieces on that round table? Usually more higher priced round tables have a Morse taper in here, but as far as I can judge, this is just a hole 6.3 millimeters in diameter and about 30 millimeters deep. So we have to create a mandrel fitting into that hole and fitting into that 5 millimeter hole here in our workpiece to center everything up. So I got myself some 1 meter 8 millimeter round stock. No mailbag for that. I got it from the home improvement market. And the long end on the other here at the back out, I fed through a 9 millimeter hole in one of my left off POM blocks. And it's working. The piece is dialed in within 1/10 of a millimeter. That's the problem with it. Extruded round stock. It's not really round and straight. And now we will make our mandrel. Forget that marking here, that's the important marking at 60 millimeters, so the mandrel total size will be 60 millimeters, it's really not critical. And about 45 millimeters will stick at a diameter of 6.3 or something millimeter, we will see, into the hole in the round table, and 15 millimeters or so will stick out at the top for centering up our workpiece. And I will first clean up the face here. And today I will give you some wider shots so you can see what I'm actually doing. Next we put a little center hole in here so we can use a live center. With everything a little bit adjusted so the live center and the tailstock here will not get into the way, we can start milling that down from 8 millimeters to, let's say, 6.4 millimeters. Okay, I come back to you when we are actually down to 6.4 millimeters. Okay, I'm exactly at 6.4 and yeah, as a sanity test I put the tailstock and everything out of the way so I can see, and I protected my waist here a little bit. If that fits into my round table, and it does, with air to breathe. So yeah, what I measured here with the inner diameter, the diameter of the hole in the round table, 6.3, that was obviously way off. I should have stopped at 6.5, but I thought a tenth should be enough. Anyway, it's a little bit of a loose fit, but it should be good enough. Everything is back in place, so now for a length of 20 millimeter we go down to a diameter of 5 millimeters. And of course the battery ran out on the first path, so I give you the second path here. We're at 5.8 millimeters now, so I take 0.3 millimeters off. And so on. I moved the tailstock out of the way so I can test that with that nominal 5 millimeter hole, which is a little bit more than 5 millimeters. But yeah, it's good enough. I should have stopped here at 5.1 and then tested it. But anyway, this is too small too, so it evens itself out. Yeah, probably not. And now we part the whole thing off. Finally, we clean the end that we just parted off here. And now we can use our mandrel to center up our piece here on the round table. I have to admit I cheated a little bit. Put a little bit of Scotch tape around here at the top and the bottom to get rid of the tolerances. After we centered our workpiece, we have to clamp it down somehow. And there are, of course, special clamps for that, but I don't have any of those. So a few bolts with washers will have to do, and we need some kind of bracket here. And I already thought of some 20 by 20 by 2 square tube aluminium here, and we will machine some slot here for the bolts to go through. First I cleaned off the sort of end, and that saw cut here, okay, that's not from me. I just wanted to point that out. Now that's the side I did cut off myself. Okay, I only had to take 0.5 millimeters off here and it's nice and clean, but I will now take a little bit more off so I get 100 millimeter in length, but I'll do that off camera. All that's left to do is to mill 2 slots in here for the bolts. And yeah, I stopped the slot here 7 millimeters before the edge, so it's a 6 millimeter slot. So I will have at the end 7 millimeters of meat all around. And in the middle, I leave a gap of 20 millimeters. Now we can clamp down our part nice and tight and work on that radius here at the front. Now the next part we need to center up on our too small round table are the side pieces. And we have to cut, of course, a radius here, a big radius. And in that case, it's actually quite nice that the round table is a little bit smaller in diameter than I intended, because I don't have to put anything below the piece to raise it up, so I won't mill into the round table. And we have to mill also a little round pocket here to take up here the boss at the end of our shafts. So mandrel top diameter is obviously the shaft diameter, so that's easy. And yeah, the inner diameter here, the lower diameter here that goes into the round table, I will be more careful this time and try to get a better fit. Anyway, I have this only 5 centimeter of 18 millimeter aluminum round stock left, and I will use that to make the mandrel. You know the drill by now. First, clean up the face. Second, just for good measure, drill a center hole. And obviously, I totally forgot to film that. Anyways, third, turn the outer diameter here down to, from 18 down to 12 millimeters, probably 11.95. That's the measurement of the shafts here. And then we go from there. And that was the whole operation. And now we turn it around and turn the other side down to, I don't know, 6.4, 6.5, we'll see. By the way, that's the longest chip I produced so far, about 160 centimeters. I won't film most of the other side because, well, it's very similar. I come back to you when we're approaching 6 point something millimeters. By the way, this time I will creep up my diameter to the diameter here of the hole in the round table, just to be sure. And here's the finished product. It's a rough fit. It's not really a tight fit in my opinion, because there's still a wiggle in there, but it's also not going in very easy. I guess the hole in here, you would have to ream it out to get some more precision, but for now that's absolutely okay. And we can now center up our piece here, and yeah, there's almost no play. So nicely centered up. So how do we clamp that one down? Yeah, we could use, and I modified that a little bit here off camera. I lengthened that slot here. clamp it down with one of those. And yeah, to be on the safe side, I made a second one also off camera. So we can use two of those to clamp those down. My bolt is too short, of course, but when I went to the home improvement market to buy the aluminum round stock, I also bought a length of M6 threaded rod, and I will cut off two pieces now, off camera too. With the threaded rods of the appropriate length, I can now tie here down both clamps, and I'm using here my two bolts to provide the counter force here at the end. Kind of a poor man's mechanist's jigs. But I not only have to mill a radius around here, I also have to mill a radius inside here. And that works equally as well. With that technique and some longer rods and one of the side pieces here to center everything up, I will be even able to clamp down here. And yeah, this is not the final thing I will use for that. My centerpiece to mill the radius here. This will be critical, and I'm not quite happy with that setup, but it is what I can do. Now, I also have to mill a circular slot here for the O-ring at the bottom of my center part, and yeah, I need to center this up on the round table, which is a little bit tricky because I don't have a hole here. Fortunately, there is enough meat between the bottom of that hole and the top, so I can put a, let's say, 15 millimeter deep hole in here. So I marked the center at the top. And just as a sanity check, I also marked here at the edges where the groove for the O-ring will go. As I've done it many times before, I aligned a center drill on the marking here just visually, and now we drill a center hole. And now I go 15 millimeters in here with a 6 millimeter drill. That was the drill size I could just fit in here without changing my setup. Of course, I also need a new mandrel, and yeah, I turned that offline, and yeah, it's the same problem here with that hole. It's an odd hole, but yeah, centered that up. Nice. And that's how I plan to hold down the whole thing on the round table. So here is a T-slot nut, and that's holding down this, well, cross member, which is connected to some top members, actually clamping the thing down via threaded rods, and maybe I have to shorten these when it comes to the actual milling. And so I can turn the whole thing here on the round table. Yeah, it's a tight fit. It's a tight fit. And please note, these members, the top members, are pressing down where there is actually meat here in the centerpiece here, not at the thin sides. And yeah, that's it. And I have enough spacing here where the slot for the O-ring goes. So yeah, besides these thingies here, which might interfere with the head of my mill, that should be fine. That's it for today. All parts, or helper parts, or sacrificial parts I need for the round table are there. And next time we probably use the round table for the first time to finish our levers. Till then, Bye.